We're going to finish up 11.1, which is just putting the two things that we did on Friday together. So what we're going to do today is we're going to solve equations, solve quadratics by completing the square. So we're going to do it kind of in reverse of what we did on Monday. We're going to find the constant that makes it a perfect square trinomial, and then we are going to use the square root property. So the big thing in all of these problems is the setup. And, oh, it reminds me, I will have the template for the extra credit on Blackboard later today. If you want to start doing that, the directions will be on there. It's essentially the same thing. Just describe in words to a classmate how you would solve these types of problems. Since you don't have specific problems to look at, I label which section they come from in your notes. It'll be for 5 points on your next test. And if I think anyone does an exemplary job, I will also give you an added drop drill grade. So if you do really well on the extra credit, you can get 5 bonus points on your test and 1 more drop drill grade. It's going to be due the Saturday after Thanksgiving, just by midnight. Because the way it works is we have, look at my calendar. So we have class through the we have class through the 25th. That's just the Monday. And then we have that Wednesday and Friday off. The week that we come back is our last week of class before finals. So that last week after Thanksgiving is just review, Unit 4 exam, and then final exam review.
What do we do for the extra credit again?
It's going to be the same idea as last time, where you describe in words how to solve problems by completing the square. What's that?
Just for a lot more stuff then? Or just for 11, chapter 11?
It's Unit 4, which is, it's 11, 12, 7 point, it's a bunch of weird sections, random sections. So what I did is I'll put the directions, I'll put what section they're in your guided notes so you can look at all the problems. And on some of them, I'm also going to be asking prompting questions.
And if you do good on that, you get an extra?
You get 5 points on your test. If you do very, very well, you get 5 points on your test and a drop drill grade.
Okay, and that's due the last day?
It's going to be due,
The 30th.
yes, November 30th by midnight. So,
That's a Saturday, right?
yes.
Ooh, I better do that.
Well, if you're working on it, the idea is that I post it now, so like tonight when you go home, you go write up what you think for 11.1.
Okay.
Then after Friday, you go home and you just add your thoughts for 11.2. That way you do it a little bit at a time, turn it all in, get your points at the end.
Okay.
That's the idea behind it, at least. So one of the things that I'd expect to see on there is some talk about setup, because depending on the directions for solving a quadratic, your setup is different. If you're solving using the quadratic formula, your setup's different than completing the square. It's different than, or actually, quadratic formula and factoring, they have the same setup. So there's only really 2 setups. But on your drill on Friday, one of the things you'll see is you'll see 2 different sets of directions. You'll see directions that say solve using the square root property. They might be the exact same problems you saw in your drill today, or solve by completing the square, which is what we're doing today. So our setup, and I've got it in bold here, the setup is that your 2 variable terms, so the 2 terms that have x with them are on the left, and the constant is on the right. Because this left side looks just like what we ended with on Monday, where the last 2 problems on your drill today, where you found the constant that completed the perfect square trinomial. It's the same thing. That's what we're doing today as part of a problem. So the other thing you have to have for your setup is that the coefficient of x squared, so whatever a is, has to be 1. So 2 things for setup, and I'll write this on every problem. A has to equal 1, and it has to be variable terms on one side, constant on the other. And then we're going to put together the 2 things we did on Monday to solve these problems. Yes?
I thought it was the bx plus that little line right there.
Mm-hmm.
I thought it was b over 2 squared.
Yeah, that is going to be b over 2 squared. Yes. And on the same on the right side, it's going to be whatever your b over 2 squared is. So if I look at the first problem has the training wheels on, so we can see what's happening. So the directions here, solve the quadratic equation by completing the square. When you see completing the square, think to yourself, fill in the blank. Our completing the square is our filling in the blank, which was on your drill today, which we did on Monday. So my first problem is x squared plus 8x minus 1 equals 0. For all of these problems, no matter which type of method we're using to solve them, you've got to make sure you have your setup before you start going. So the first check, does a equal 1? Yes. So a is the number in front of x squared. So you got to make sure that it's just a 1 in front of x squared. If there's some other number, we're just going to divide everything by that number. So if no, fix it. We don't have to fix it here. Second thing you're looking for, do you have the format ax squared plus bx plus, leave yourself room to complete the square, equals c. So do I have my variable terms on the left and my constant on the right? No. So my variable terms are this x squared plus 8x. So right now we're looking at x squared plus 8x minus 1 equals 0. I want just my variable terms on the left. I need to get the constant over to the right. So for this problem, it's going to be adding 1 to both sides. So I have x squared plus 8x equals 1. So variable terms on one side and the constant on the other. Because what we can do now is we can treat that left side like we treated the last problems that we had on Monday. So if you remember on Monday, we had just the two terms, and we had to find the constant that made it a perfect square trinomial, write the constant and factor it. So we again have room here to find that constant. The difference between the problems on Monday and the problem now is that there's also equal to and another number on the right side. That was just part of our original problem. So what we're going to do, same thing that we did on Monday, we're going to fill in the blank for the left side. But because I have an equation now, whatever number I decide goes on the left side, to keep it balanced, I've got to add the same number on the right side. So there's two steps to that process, and I saw some people struggling with what were those two steps. So what's the first thing I need to do with b? Divide it by 2. So I'm going to take b and divide it by 2. So I'm going to take 8 and divide it by 2. Oh, I had lines for this. Well, just do it down here. It's supposed to be over here. 8 divided by 2 is 4. And then what's the second step? Square it. Completing the square, making a perfect square trinomial. So the number, sorry, I wrote it two places. The number that completes the square is 16. And that was what the last two questions on your drill, the first part of it was to find the number that completes the square. And it's that process. You divide b by 2, and then you square it. Emily?
What happens if it's a negative? Or what happens, sorry, if it can't be divided straight into 2?
Then you leave it as the fraction. So if you look back at, actually it should be down here, like d from last time, it was okay if we had a fraction. We just squared it and we could factor it from there. So if I had decided I need 16 on the left side to complete the square, to keep balance, I need a 16 on the right side as well. Any questions up to this point? Now, the reason we did that is with one more step, this will be exactly like the problems we had on Monday. So the next step right here says to factor the left side and combine the right side. So I want to factor x squared plus 8x plus 16, which means I'm looking for a pair that multiplies to 16, and at the same time that pair adds to 8. X plus 4, x plus 4. So our way of writing that kind of compactly is x plus 4 squared. So the left side should factor as that perfect square trinomial. And the right side we just want to add together. Add the 1 and the 16, we get 17. So we go through this completing the square process like we did last time, and we add that number to both sides. Then we factor the left side and just combine together the right side. And now this problem looks like the second problem on your drill. It looks like a bunch of the problems that we did on Monday. To finish solving this, we use the square root property. So on the left side, I want to get rid of this squared the easiest way possible, which is not FOILing it. What's the opposite of squaring something? Square rooting. So I'm going to take the square root of x plus 4 squared. It's going to be equal to the square root of 17. But what else do I need on the right side? Plus or minus. So don't forget your plus or minus. We don't know what the value is, if this is positive or negative, the thing we're squaring. So we have to include both the principal and negative root there. Then on the left side, the square root and squared will cancel each other out. So I have x plus 4 equals plus or minus the square root of 17. And then what do I need to do to finish solving for x? Subtract the 4. And when I subtract the 4 on the right side, where do we tend to put that? Yeah, before the plus or minus. So we're looking at x equals negative 4 plus or minus the square root of 17. And before you box your answer or you put it on your answer line, always check your radical to see if you can simplify it any further. So can I simplify the square root of 17? No. And if you want to show your two answers, you have negative 4 plus the square root of 17 and negative 4 minus the square root of 17. But this one is okay to leave as the stacked plus or minus because it still has a square root. If your answer has a square root or an I, it's okay to leave it stacked. If you don't have either of those, that's when you have to break it up, and we will see one of those today. Questions? Mm-hmm.
Say when when you say x squared plus 8x plus 16
Mm-hmm.
equals the 1.
Mm-hmm.
I mean 17.
Mm-hmm.
If the x squared, if it wasn't a 1, like say it was a 2, and I divided the 2, would I have to divide it into the 8 too?
Yes, into everything, even the 1. And we'll see one of those in a little bit. I don't think it's next. No, we'll do that and see. So for B, we want to solve the quadratic equation by completing the square. So there's two parts to your setup here, and if you choose to do the extra credit, you should mention some things about your setup. So the first thing for your setup for completing the square is that you need to make sure A equals 1. So in my problem in B here, do I have A equal to 1? Yes, A is the number in front of, in this case, y squared. So there's nothing there other than 1, so we're all set. The second part of your setup that you're looking for is that you have your variable terms equal to your constant. So that means anything with an x is on one side and the plain number is on the other. Is that true in this problem? Yes. So that means I'm good to actually go to start completing this square. So I'm going to leave myself some room on the left side to complete the square. And I use a blank for that. And whatever I end up adding to the left side, just to keep balance, also has to get added to the right side. Now there's two steps to find that number. First thing you have to do is take B and divide it by 2. It's always divide by 2 to start. So that's going to give me 3. And the second step, for completing the square, we're making a perfect square trinomial. You need to take the result from dividing by 2 and square it. So you divide by 2 and then you square that number. So in this case, 9 completes the square. Now that we've got my blank filled in, on the left side you should see a polynomial that you can factor, and on the right side you should see two numbers that you can add together. So for the left side, I want to factor y squared plus 6y plus 9, so I need my pair of numbers that multiplies to 9. At the same time, the same pair of numbers adds to 6. 3 and 3. So as a compact factor, we have y plus 3 squared. And then on the right side, negative 8 plus 9 is 1. And now we're back to the square root property, which was on your drill today, which we worked with on Monday. So when I see this, the quickest way to solve it is to just get rid of the squared on the parentheses. So what's the opposite of squaring?
Square root.
Square root. So I'm going to square root y plus 3 squared equals, don't forget your plus or minus, the square root of 1. On the left side, the square root and the squared cancel. That's why we're doing this process. So we're left with y plus 3 equals plus or minus. Now you can leave the square root of 1 here. It's really up to you where you start simplifying, but if something's perfect, I tend to simplify it. I don't copy down the perfect square root. What's the square root of 1? 1. So I have y equals 3 plus or minus 1. Sorry, y plus 3 equals plus or minus 1. And now to finish solving for y, we've got to subtract 3. And this is really why one of the places that it's important where you put that negative 3 on the other side, because it tends to confuse your answer if you put it in the wrong place. So just like we did with all the others, we're going to sandwich that negative 3 in front of the plus or minus. So our answer is y equals negative 3 plus or minus 1. But this is the one time you have to break that up. There's no square root, there's no I, which means those are like terms, which means I'm going to get two distinct answers here. So when you break it up, just like I broke up other ones, you see negative 3 plus 1 as one solution, and negative 3 minus 1. That's what your plus or minus means. It means there's really one answer with a plus there, and there's one answer with a minus there. Negative 3 plus 1 is negative 2, and negative 3 minus 1 is negative 4. So how you know to do that on this particular problem? After you get down and you have your plus or minus there, there's no square root, there's no I. These are like terms, which means I will be able to simplify them further. What the plus or minus means is you take the two numbers around it, first with a plus between them, and then you take the two numbers around it with a minus between them. And then you can simplify. Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. So there's two integer solutions to that. Other than that, you're welcome to leave it stacked, plus or minus.
Math is the least logical subject I think I've ever learned.
It's very logical. That's why.
Yeah. How logical is all the answers negative 3 plus or minus 1? Okay, what?
Well, try it.
Oh, I did. Oh, I saw you try it. But
No, I mean try it. So let's just
no,
think.
I understand how it makes sense. It's just very abstract. You know what I mean? Like to look at an answer.
This-
It's negative 3 plus or minus 1.
This stuff is not very abstract.
Okay, well,
I've gotten into the abstract stuff, and it gets out there really
Do you
fast.
teach 111?
I do not. I do not teach anything after 083.
Do you recommend any teachers?
I can look at the schedule and recommend somebody, yes.
Is there anybody that would fit me?
I'd have to warn them you're coming, but I could probably find someone for you as well. I had something else to say on this. I don't remember now.
Oh, sorry. I need to get you off.
That's all right. Questions? Questions? Well, you'll notice that I just do the same thing every single time. And actually, completing the square has great applications. like in my grad level math classes, we still complete the square places. We used to get an application here when we did circles, but they dropped it this semester. So we actually will not get to see how you could practically use this. But if you want to graph a circle, you complete the square. So this has got a lot of applications. Mine was actually in mathematical finance. We completed the square.
Oh, wow.
So yeah. It's out there. Again, you probably won't see it, but it's there. So solve each quadratic equation by completing the square. Now the directions. Who reads the general directions on their drill every day?
I tried to.
The general directions. Well, let me read them to you now so that we know for next time.
Oh, actually, I read mine.
Solve each quadratic by the specified method. Problems solved by other methods will not receive any credit. Show work for full credit. Simplify answers. Meaning, it makes a difference whether or not you complete the square here or use the quadratic formula. You have to complete the square. The same thing will happen on your final. When they give me your final, it has specified methods. So, to complete the square, let's talk about that setup again.
Oh, that's what's
So, first thing we need is we need a equal to 1. So, what's a in this problem? 2. I can't have a equal to 2. So, as Sarah said, to get rid of the 2, we just divide by 2. You divide by whatever a is. To keep balance, you got to keep balance in equations. You just divide everything by that coefficient. So I have x squared plus 4x equals negative 6. So a equals 1.
So if there's anything to divide by, do
Mm-hmm.
that first.
Yep. So we're going to divide by a if it's not 1. So we had to do a little fix here. Second part of your setup is that we need our variables. I'm going to abbreviate that. Variable terms equal to our constant. Do I have that setup met?
Yes.
Yes. So now I'm okay to actually get into completing the square. And completing the square entails finding the constant that makes a perfect square trinomial. So without shouting it out yet, find the constant that completes the square.
I mean, 4.
Without shouting it out yet. We're working on directions.
She was excited. 4.
All right, so there's 2 steps to finding that constant.
I was kidding.
We're going to take b and divide it by 2. And that gives me 2. Second step, square it. So the constant that completes the square is 4.
Alright, this is coming along.
All right, so we're going to do right, listen. Raise your hand if you want to answer the next question. Who's got the factors for x squared plus 4x plus 4? I haven't heard from you, Mindy. What do you got?
2 and
2 and 2. So what's your factor look like?
x plus 2 squared.
X plus 2 squared. So the pair of numbers that multiplies to 4 and adds to 4. Can I get another hand raised? What's happening to the right side? Lisa.
Combine them.
Combine them, and what do you get when you combine them?
-2.
Negative 2. So that setup there just makes the problems look like what we did on Monday. It's just taking the second step on Monday to get us to the first step. It's exactly the same. So now to finish solving for x, we're back to the square root property. So I'm going to take the square root of x plus 2 squared equals plus or minus the square root of negative 2. So if you forget the plus or minus, what I recommend is that when you come to a final answer, you always split it. Get in the habit of, even if you don't have to, always splitting it. Because if you get to that point and you can't, you know you forgot the plus or minus.
Okay.
That's my recommendation. So on the left side, the squared and the square root cancel each other out. So I end up with x plus 2 equals plus or minus the square root of negative 2. And then to finish solving for x, I'm going to subtract 2 from both sides and sandwich it in before the plus or minus. So negative 2 plus or minus the square root of negative 2. And to finish solving, or sorry, we're solved now. To finish simplifying, what could I do for the square root of negative 2? Yeah, it's an imaginary number. So you could either, this one is one that you probably could go right to how to write it in terms of I, or how could I break up the square root of negative 2? Yeah, square root of negative 1 times the square root of 2. You don't ever want to leave a negative underneath the square root, because we know how to write that in terms of our imaginary unit I. So the square root of negative 2 is the same as I times the square root of positive 2. Now, this I square root of 2 is just another way to write the square root of negative 2. So the plus or minus is still in front of this. You don't want to try to like cram it in between the I and the square root. So it's x equals negative 2 plus or minus I square root of 2. And if you go to split that up, you have x equals negative 2 plus I square root of 2 and negative 2 minus I square root of 2.
But for that, could I just leave it with the plus or minus?
As long as you remember the plus or minus, yes, you could. Because there's actually both a square root and an I, which means that they're not going to be like terms with the negative 2 out front. So it's okay to leave this one stacked. The only time you can't is if it ends up like the previous problem, where there's no square root and there's no I. Questions?
When does the plus or minus get added into the whole thing?
It's a great question. When you go to the line where you put the square root around the number, that's when the plus or minus comes out front.
Okay.
So when you start drawing square roots, that's when you also add in the plus or minus. Any other questions? All right, so our last one, solve by completing the square. X squared minus 10x plus 1 equals 0. Setup for completing the square. First thing you need to check is that a equals 1. Do I have that here? Yes. So that portion's all set up. Second thing is we need variable terms equal to the constant. Do I have that taken care of? No. So I'm going to have to fix the setup for that second condition. And that's going to require subtracting the 1 from both sides. So now we have x squared minus 10x on the left side. Leave yourself room to complete the square. And the 1 has gone as a negative 1 over to the other side. And I'm going to put the blank there as well, because what we do to one side, we have to do to the other. And now we need to find the constant that completes the square. So take your b, divide it by 2, get a negative 5, and then square it, which gives me 25. So 25 completes the square, and if I have 25 on one side, if I add it, to keep balance, I've got to add 25 to the other side. What should we do next with the left side? Multiplies to 25, adds to negative 10. Kent, what do you have for that? X minus 5 squared. And the right side, add it together, we get 24. Now we're back to the square root property. We're back to what was on your drill today. And again, you will see problems from your drill today on the drill on Friday. Maybe not the exact same ones. You might get lucky. You might get the exact same ones. But it will be a mix. So I'm going to take the square root of x minus 5 squared equals plus or minus the square root of 24. On the left side, the squared and square root will cancel each other out. So I have x minus 5 equals plus or minus the square root of 24. And to finish solving for x, add 5 to both sides, sandwiching it in front of the plus or minus. So I have x equals 5 plus or minus the square root of 24. Am I ready to box my answer yet? No, why not? And break up the square root of 24. I am. It's fine. Absolutely okay. So I usually save the simplify till the end. It really doesn't matter where it happens. It's the square root of 4 times the square root of 6. So I get x equals 5 plus or minus 2 square root 6. Yes, if you want to simplify it up here, it's absolutely okay. It makes no difference where you simplify it. So as my two answers, I have 5 plus 2 square root of 6 and 5 minus 2 square root of 6. Still got one more. I got 5 minutes.
I thought you said that was the last one.
That's the last example. Now I gotta see that you know what you're doing. We got 5 minutes. I'm getting your money's worth. Solve by completing the square. Should box that. So we have 3x squared plus 24x plus 12 equals 0. Solve by completing the square. And you're allowed to work with people around you. You ask me questions. Solve by completing the square.